Hi everyone, welcome to this lecture. So in the previous lecture, we learned that we cannot use linear regression model to perform probabilistic classification. Therefore, we need to transform linear regression model into the logistic regression model. We also observed in the previous lecture that we need a model like this. So linear regression model cannot provide us this kind of a model. So how to get this kind of model in order to transform linear regression model into this kind of model? So luckily in mathematics, we have a function known as sigmoid function. So this is the shape of this sigmoid function, and we can see that its minimum value is 0 and its maximum value is 1. That is, it is ideally suited to perform probabilistic classification because its value ranges between 0 and 1, and the range of probability values is also between 0 and 1. So this is the mathematical representation of a sigmoid function. So we can see that if I put z is equals to 0, here I have written this function in the form of z. So we can use any variable in order to represent this sigmoid function. We can write it in the form of phi x, phi y, phi z, or we can use, or phi t. We can use any variable in order to write this mathematical form of the sigmoid function. So if I put z equals to 0 here, so it will become exponent raised to power 0. And we know that anything raised to power 0 will be equals to 1. So we will have 1 here and 1 here. We will get 2 at the denominator. So the total value will be half. It means when z is equals to 0, this function will give the value which is equals to 0.5. So 0 is the important point where we are getting 0.5 from the function. Now, if the value of z is negative, that is, it is less than 0, then we will get the value less than 0.5. And if we keep increasing the value of z towards negative direction, we can see that this function is approaching towards 0. That is, if the value of z is minus 10, at minus 10, its value is 0. Similarly, if we put the value of z which is greater than 0 in the sigmoid function, then we will get the value greater than 0.5. And if we keep on increasing the positive value, it means we are reaching towards 1. So for positive values of z, it will give us the values greater than 0.5. And for the negative values, it will give us the values less than 0.5. But its minimum value of this sigmoid function is 0 and the maximum value of this sigmoid function is 1. So this is an ideal situation, or this is an ideal function which can be used to transform linear regression model into the logistic regression model. So here we are going to perform the transformation of linear regression into a logistic regression. Now, this is my standard linear regression equation. So this standard linear regression equation is representing this straight line, which is in red color. Now, if I want to transform this straight line, or if I want to transform this linear regression model into the sigmoid function or into a logistic regression model, I need the sigmoid function. So this is the sigmoid function, and here I am using a variable y. So if I put this y, if I put the equation of linear regression here in the sigmoid function, then I will be able to transform it into the logistic regression. So we just need one step in order to transform a linear regression into a logistic regression. That is, in order to transform a linear regression into a classifier which can give us the probabilistic classification. So here is the logistic regression, and the output of the logistic regression is the probability of a class. So we can see that in the just performing the one step, we are able to transform linear regression into the logistic regression. Now, this is the equation of a logistic regression. So here P represent the probability of predicting the class or a target variable. Since this is the probability of the prediction, so I can replace this P by ypred, that is the predicted label, by the logistic regression model. Now just perform few mathematical steps. So I'm going to perform few steps. So I am moving this denominator from the right side of the equation to the left. So here is my value. So after this, there is only 1 which is left at the right side of the equation. Now multiply this y pred inside this parenthesis. So if I multiply y pred with 1, I will get y pred. If I multiply this y pred with this exponent term, I will get this term, and there is 1 at the right side of the equation. Now, after this, I am performing the step, that is, I am moving this y pred towards the right side of the equation so that it becomes a negative. So here we have moved this y pred to the right side of the equation. So it will become 1 minus y pred at the right side. So here is my left side. Now I am going to perform two steps simultaneously. That is, the first step is that I am moving this 1 minus y pred from right side of the equation to the left. So it will become the denominator of the left side of the equation. Similarly, I am moving this exponent term from left side of the equation to the right side of the equation. So when I will move this exponent term, its sign of its exponent value is changed. Previously, it was a negative sign, and now it becomes the positive sign. So this is my final equation for the logistic regression, where y pred is the probability of an event happening, and 1 minus y pred is the probability of an event not happening. Or we can say that y pred is the probability of predicting a class, and 1 minus y pred is the probability of not predicting a class. So we know that the probability of the events should be equal to 1 if we add their probabilities. So if I add y pred and 1 minus y pred, I will get 1, because this y pred is with positive sign and this y pred is with negative sign. So if I add this term with this term, I will get 1. So this is the representation of the equation of logistic regression. That is, logistic regression give us the probability of the class. So we have converted linear regression solution or problem into a logistic regression solution by placing linear regression into the sigmoid equation. So that was the key step, that by putting the standard linear equation into the sigmoid function, you transform linear regression model into the logistic regression model. So in logistic regression model, we will use a cutoff point of 0.5. That is, the threshold value or cutoff value is 0.5. So any data sample whose probability will be equal or greater than 0.5 will belong to class 1, and below 0.5, it will belongs to class 0. So in this lecture, we learn that the most important function is a sigmoid function, and we use that sigmoid function to convert linear regression model into a logistic regression model. So I hope you understood this transformation. Thanks for listening, and I will see you in the next lecture.